Thank you, thank you. Yeah, I'm going to talk today about the structure of PDFs and places where you can hide things. Who am I? I'm currently a technical writer for a prize who do lots of document processing software. By technical writer, I don't do documentation. I write technical articles as blogs. So I've written about 70 in the last year, so it's quite a lot out there. I've been working with PDFs for most of the last 10 years, and I'm a second-time speaker here. Last year I spoke about access violations in PDFs. And my weird, because Alyssa says we should lean into our weird, is I like pirates and AI things. So as I'm going to lean in, we'll stick the other hat on. So, and also Alyssa was saying, when she was young, she, took things apart and worked out how they worked. Now, this is a true image of my garage at the moment. I wouldn't tell you a lie because I'm not the kind of person that tells lies. Okay, so why this talk? It's your fault. Normally I can blame not Charlie, but this time I'm going to blame you because last year I came here, saw the CTF challenge, and I thought, you can hide things inside images, for example. I bet you can hide things inside PDFs. So I went back to work and I started hiding things in PDFs to give to my colleagues as challenges. And I started with simple things like transparent text, and I thought, that'll be hard to find. And they used tools and they went, yeah, it's that. But it turns out there's a lot of places where you can hide things in PDFs. So what we're going to look at today is the structure of PDFs generally as a format, some of the places where you can hide things, and you will know many more, and some open source and free tools that are out there. There's some very good paid tools as well, but we won't talk about those today. So why PDFs? They are everywhere. There are trillions. Here's 5 different ones, for invoices, books, pay advices, I like those, and so on. And they are seen as the equivalent of paper. And they're trusted because of that. And they absolutely shouldn't be trusted, at least straight off. So the PDF file structure, it started off defining where ink goes on the page. And there's nothing more than that. But it's actually much more like a programming language as it's evolved, rather than a file format. And whilst it started as ink on the page, it then got bits added to it, and bits added to it, and bits added to it, rather like this talk will be. Because when I started, I wrote a few lines to the submission here, and they said, that's good. And when I started writing this, I kept going, oh, I should squeeze that in, and that. And then you do some research and go, oh, and that doesn't work. So anyway, latest version 2, lots of apps still create old versions. Lots of apps out there create broken things, which Adobe Acrobat will open, even though they're out of spec. And because Adobe Acrobat is by far the biggest player in the market, they dominate what people do. And people say, Acrobat does it, your software should. So other people are forced to also use out-of-spec docs. So the actual version 2 specifications, about 1,000 pages long. I've got less than 25 minutes for this talk. So I'm going to skip a few bits, which is just as well, because I haven't read all of it. But, at the end of it, we'll all be friends together and we'll know more. So let's look at PDF structure for beginners. And if you look on the internet, you'll find all kinds of examples like this. This came from a guy in Australia called ironmoon.net. He had such good images, I thought, why recreate them? I can just steal them. And he actually said, that's fine. So what we've got is, we've got the header at the top, and it says %PDF, and the version 1.4 in this case. We've then got the body, which is a collection of objects, technically known as COS objects. Doesn't really matter. There's a pointer here somewhere. Pointer. Here. This thing here, that's 20R. That's a reference to another object. And the page is another reference to an object. And the references are all held in there. Woo! And at the bottom, we have the footer, which says how many things are actually in the thing. what's a root object, and the location in the file for the start of the cross-reference table. And that's great. Problem with this is you have to read the entire file to the very end to find out where the first thing is. But anyway, we'll assume that's fine. Let's see how it actually, within an object, draws some text. And it's actually done in a stream. This looks complicated, but we're clever people, we'll work it out. So the first thing is the length of the stream. Next, we've got a couple of tags to mark the beginning and the end of the stream, where the text starts, what font we're going to use, which is a whole lot of magic built into PDFs. In this case, where we're going to draw it on the screen, what we're going to write, and then there's an operator for actually saying the program that we're going to do to actually do this. In this case, it's write some text. And when we put all that together, it says, "Hello, Con 2024, it's great to be here." And indeed it is. And thank you for being here. I would feel very lonely if you weren't. So let's look at our first tool, which is Notepad. And we'll change the font definition. So in here at the moment, we've got the font, and it's Helvetica. There are a number of ways that you can specify a font in a PDF. There are 14 fonts that are built into the standard. Helvetica's one. If you say Helvetica, the reader is assumed that it will have Helvetica available as a font. So at the moment, it's coming out like this. And we can use Notepad++, and we can change Helvetica to Courier. I've done a wee shimmy there to make it that the positions of the objects are the same. And ta-da! Simple as that. So at this point, you should be thinking, I understand how PDFs work. And all I need to work with them is Notepad++. And in fact, there's lots of examples on the web that show you about this. So, you know a bit. It gets a little more complicated because there's incremental update. So we start off with the same basic structure, and then you can edit PDFs, right? It's not like a fixed thing anymore. And if you make an annotation, or you remove something, or do anything else, you end up with a whole lot of changes. And you could write the entire new file back, but that gets difficult if it's a big file. Or alternatively, you can just calculate the changes and stick them on and say, read the first one, and on the second one, ta-da, that's easy. I can understand that, there's only one change. Yeah, okay. It's getting harder. And then we have linearization, which is an alternative way of representing or structuring the file. So we said one of the problems with the PDF file format is you have to read right to the very end before you can do anything. This saves that problem. What it does, it's got the very start, it's got information about the first page, and all the objects that are needed for the first page are together, which is kind of handy. So there's no need to bring everything down, and it's got multiple cross-reference tables, one for the first page, one for the rest, and you can actually do random access. So if it's streaming over the internet, you can bring it down that way. That's pretty cool. But you would be thinking by now, this is getting a bit harder. And you'd be right, because then you find the PDF marker, which I said is the first thing in the file, doesn't need to be the first thing in the file. Technically, first 1,024 bytes, anywhere will do. The objects don't need to be in ascending order. They can be in any order, because you've got a cross-reference table to say where they are. Some objects aren't even necessarily present there at all, because you can have an object and then free it. This happens particularly with the incremental update. So it was there, it's gone, take it out of the cross-reference table, no one cares about it. And the cross-reference table may not be at the end, or visible like we saw. And if that wasn't enough, then you find that the text may be encoded. So instead of hello, Shikon and all that, it's now, oh hell, it's gone into octal or hexadecimal, or some really, really weird stuff. With all this, it's saying, this is the first character in the font, the second, the third, the fourth, all the way along, using a mapping that goes to heaven only knows where. And then we find that the streams may not even be plain text. So in this case, they've been compressed using Flate, but they can also be encrypted on top of being compressed. So by now, you're probably thinking, well, you're certainly thinking I need help. You probably need help as well. And maybe Notepad++ isn't enough. So let's look at our first, or actually our second tool, CosEdit. It's actually by Apprise, the company I work for. It's browser-based, it's free, and it allows you to decompress streams. And it's a very simple one. You can also view things to pull out the individual objects, and you can edit them, which is pretty handy. So let's use the PDF I created from my talk last year about access violations, and we'll open it in CosEdit. So it's a bit complicated, but we're clever, we'll work through it. So the first thing we've got, just to make it bigger, we've got begin text and end text, just as we had before. We've got a font specified, slightly different way from before, but the same idea. We've got the right text operator and the actual text. So we can see it says access violation. Superb, just what we wanted. And then you're going to go, hang on, there were other things in there. I think you're trying to hide something from us. Well, other than that's the entire point of the process, what we have is we've got offsets. So these allow us to specify the individual place where characters will be located. And we can use it to adjust to the kerning, or the kemming, as the joke goes. One laugh. More laughs. Hey, they are awake. So let's have a look at how they work. So we've got, in this case, hello Chacon. I've put some offsets in there, and it's just saying, take the first letter, and then there's a 1 after it. So move where you're going to write the next one on by 1 position, write the next 2, the EL, move it on by another 1 position, and so on. That's pretty handy. One of the nice things you can do for obfuscating text is you can write it backwards, because there's no reason that you can't write the end first and then keep stepping backwards to get earlier to write the next characters. Okay, we can take this a little further, and I know what's on your mind. It'll be pizza. And of course, because you're keen on pizza, that's what you're reading. Or is it actually a pirate huzzah? Because we can take pirate who, -7, bring it backwards, draw a rectangle to hide some of the text, do the ZZAH on top of it, write another rectangle, and suddenly we have pizza, even though if you copy and paste that, it's not what it says. So our second tool, PDF Box by Apache. It's open source, Java-based, you'll need to compile it. And one of the things I like it for is that it lets me see what fonts look like. So in the last one, the Pirate Huzzah one, or Pirates, we can see, hopefully you can see this. If not, move closer. We've got the individual fonts. And hey, look, it got bigger. That's like magic. And we're saying, we're using the letter P, we're using the letter R, S, and T, because they're all in Pirates. But the other letters that we didn't use aren't actually in the font at all. So this is an embedded font, or an embedded subset font. It's a major problem if you're trying to work with PDFs for editing them, because you can find you haven't got all the fonts you want. But that's not what we're talking about today. Okay. So let's look at actually hiding some stuff, because that's what the talk's about. So the first obvious thing to hide is using JavaScript. And if I click on a button right in the middle, it says, hello, and the button, of course, is hidden, so you can't see it. This brings us on to our fourth tool, called RUPS, which is by iText, who are were one of the major PDF-producing libraries. It's now part of the Apprise family. And you can see here there's a whole lot of information, much of which is the same as CosEdit, but we can dive into it a little deeper. And for example, here we can see we've got, this is where the JavaScript's happening and what was written actually in the JavaScript. It's in the file. That's fine. It's a bit slow to go through finding all these JavaScripts, So another way you can do it is you can use our fifth tool, which is peepdf.py. I don't know if you've come across this. It will let you parse the PDF in a single operation. It's Python-based. Where did the pi come from? And it will show you suspicious objects. So it's saying straight off here, oh, we've got suspicious elements. You might want to look at these things. It's a bit dated. It's still useful. It doesn't work with PDF 2.0. By all means, Python experts out there, I know you're there, update it. It'll really help me. It's got an interactive mode, and we can actually then start looking at individual objects. So in this case, if we look at object 29, we can see object 29, and that's the entire content of that. And you can see how things reference together. It's not very exciting in this example. It was a wee app because actually installing malware on my work machines is generally seen as a bad idea. And I get phone calls about that. But we can use the same tool with other malicious PDFs. For example, this example. And this is saying not only that there was something suspicious, oh, look, it's got a CV associated with it. And if we dig into that particular element, it will show us what all the code is. If I had that on my machine, I'd go, ooh, that doesn't look right. peepdf is a great tool in itself, and it's actually part of a tool set. So you can download it by itself, or you can download Remnux, which I hadn't come across till I started writing this talk. But Remnux is an Ubuntu-based distro, which I run inside VirtualBox, and it means I can do a whole lot of different analyses on tools. So you've got all of these in here. We've got Visual Studio, not that that does anything dodgy with things, and tools that you'll recognize. And it's great because it comes down and if you make a mess of it, you throw it away and get a new one. Okay. Some other places to hide things. And this is still working within the intended way that PDFs work. And I'm not going to go into much detail here because we're short on time. We can talk about it later after. Metadata, it's actually two kinds of metadata involved with PDFs. Yeah, you can hide stuff there. Layers, where you can actually swap things in so they can be in front of each other or behind each other. You can turn them on and off. You can make it that you can't turn them on. That's pretty good. Whilst being hidden. And attachments and portfolios. These are particularly interesting because basically you can use a PDF as a container of any other object type. And in this case, some of the objects we've got down there, oh look, there's an exe file. So an exe file inside a PDF that you can ship to someone and go, it's not even there. And the great thing is, depending on which way you view the PDF, it will look entirely different. This is the same PDF in 4 different viewers. This is a Prize web viewer, which is showing you the actual front page and the contents. This is Acrobat, which is not showing you the front page, but is showing you the contents. This is Foxit PDF Reader, which is only showing you the contents, but not the front page. And then we have Chrome, I think, which is just showing you the front page, but not the contents. So depending on how someone looks at a PDF, it can look entirely differently on their desk. So if someone says, I've got a dodgy PDF, how are they looking at it? Okay. So next, let's look at where we can hide things, not so much in the PDF, but in the file itself. And this was our file structure, fairly standard as we found on the net. But in reality, it's much more like this potentially, because there's no reason whatsoever that the header has to be at the start, as I mentioned briefly. The objects don't need to be near each other. There can be huge gaps in between them. The cross-reference table doesn't have to be right at the end, and the footer doesn't have to be the last thing in the file, which means there's a whole lot of potential to hide things in gaps, which is great for people like me that likes to hide things. So, as an example, here be pirates written at the top of a file before the PDF header. And PDF viewers, every single one I tried, perfectly happy to open this file. It's entirely valid. Similarly, we can put exactly the same kind of pirates thing in between objects. That's also perfectly valid. Acrobat will open it without any problem. So it's fun to put bits of text in the middle of the file. What about doing something a bit bigger? So we can, in fact, drop a lot of data into these gaps. So this is between the first PDF header and the first object. And we've got a whole lot of stuff in here. In fact, it's an entire file definition. And this is not seen as an error by peepdf.py. And the reason I'm doing it in this case is it's actually for good and not evil, because this is a DICOM file. So DICOM files are used in medicine for all kinds of medical imaging. And it turns out that you can have the same file that is viewed entirely differently, whether it's a PDF, open in a PDF viewer, or a DICOM viewer. And this has got real benefits, because you could give the customer the file that's got all the information in that's about them, and they can read the summary, and if they had a DICOM viewer, they can read the details. But it's the same file, and it's keeping things together in a really positive, useful way. Okay, next, let's look about actually storing things within objects. Now, I said about objects can be freed. So in this case, we've got this object here, number 6, has been freed. So the F indicates no longer in use. And you can put anything you want into one of those objects, and it will not be an error unless something else makes that file corrupt. Typically, it goes corrupt if the number of elements in the cross-reference there doesn't match this. If not, that'll quite happily open within Acrobat or other tools. Okay. What about some weirder places to hide things? Because this is all fairly straightforward. What about hiding information, whatever it might be, not necessarily malicious information, because I'm a good guy, but hiding things in the glyphs of a font. So the actual glyphs are what define the way that a letter looks. What does an A look like? Well, it can look like any of those. That's perfectly reasonable. As humans, we identify those are all A's. And there's tools that let us define our own fonts. If there's not enough of the 60,000 odd fonts that are out there, we can use FontForge and create our own font. And this looks like an A, but for Fenrir, that's also an A. Or if you're a Klingon, that's an A. Or indeed, if it doesn't have to look like an A, why can't that be an A? And this means that we could hide a flag of some sort entirely in the glyphs in a true type font. So in this case, this clearly says nothing to see. And yet if you copy and paste that into Notepad, good old Notepad, it says, Flag Kazakhstan! Hooray! No one found that. No one tried. And the reason this is happening is I created my own font. I know, again, it's a bit small, but the F at the beginning is translating as an N, is the way it's rendered. The L's rendering as an O, and so on. When I get to the second day in Kazakhstan, or the first day in Kazakhstan, the second one was in flag, I can't reuse A again, so I'm going to have another font. So I ended up with 3 separate fonts, all called Roboto, something or other. I found out, for your benefit, I would like you to be aware of this, this screws up the fonts on your machine. I've done it, you don't have to. Better still, Windows can't keep a secret. Well, we found that yesterday. In this case, the tooltip it gives you gives away the bloody answer. Oh, well. But there's actually something serious here, because if a character doesn't have to be what you see, how do you know when you get an invoice and, someone from the rates or whatever, and you copy and paste the account number from the invoice into your bank account, how do you check that what gets pasted in is correct? Because it doesn't have to be. You know, you've got your 10-digit number, maybe another 10-digit number gets pasted in. You've only got to get it right once or twice. It's a good money maker for bad people. I'm not a bad person. So, okay, let's look about code inside a font. And this is the only bug I'm going to talk about today. Everything else is kind of within spec. So, someone spoke just before lunch, and they mentioned matrices for calculations. This is another font matrix, or this is another matrix. In this case, it's a font matrix. And when you define a font, you've got to specify, where the coordinates are to draw it. And you could do it, in very small numbers, or you could do big numbers. Big numbers are easy to work with. So in this case, you make it 1,000 times bigger than you want, and then we're scaling it down by 1,000 times to make it exactly the size we want at the end of the day. Now, there's a bug in PDF.js, which is a widely used PDF viewer with many thousands of downloads, and its derivatives do as well, and it's used by Firefox. And the JS in PDF.js stands for JavaScript, and JavaScript's not type safe, which means that potentially you can stick something into that matrix that's not a number, which is like almost a squealy thing. I never heard it called squealy till yesterday. Things I learn. Okay, so in this case, what I did, and again, sorry, it's a bit small, but we've got the font matrix up there. I'm putting in something there, and then I'm saying, stick an alert that says flag Bolivia. You save it, and when you open this PDF in PDF.js, or the vulnerable version, it pops up and says, flag Bolivia, it's JavaScript. Hey, just because you used a font. Now that bug's been fixed, at least in PDF.js, who knows in derived software. But there's many other kinds of matrix used within PDFs. So there are possibly similar bugs in other libraries that are based on JavaScript. Okay, so I'm coming towards an end, which is probably good because they'll be pleased. What about more than nonsense in the gaps? At the moment, I've shown you can put a piece of text in the file, and that's fine, it works. And we saw that you can have your PDF and you stick a whole DICOM file actually in it, and that works, and that's really useful. But what about putting a script into a PDF? So in this case, we've got a PDF, just fairly standard. We've seen this a few times. And I've put a bash script in the top, so it's going to echo and say, hello world, and then do something with curl, whatever that is. And in this case, when I run that, if I can persuade someone to run this using bash, because bash doesn't care about the file type, it's a PDF, but bash is only interested in those first few bytes, it will happily echo hello Chacon and download a file for me onto my machine simply because I opened the PDF, or didn't open the PDF. If I was really smart, the next thing in the script would open the PDF as a PDF. No one would know. In this case, the file I downloaded was the article that I wrote from last year. So do you trust passwords in PDFs? So this got added for Nathan because I spoke to him in the bar last night. He said, you should tell these people. So PDFs can be encrypted with a password. The whole point is confidentiality, The trouble is, PDFs can contain both encrypted and unencrypted objects in the same PDF. And it's actually possible, without knowing the password, to be able to replace one of the encrypted objects with an unencrypted one, and it will still open, potentially. By the way, bad actor, that was me. I got mentioned in the paper for that. I was very ominous, pointing. So, finishing up, PDFs are not the same as just ink on the page. But we've got so used to them, we trust them just because they're familiar. You can squeeze all kinds of things into them by design. You can squeeze things into them without breaking the specification. You can actually Break the specification quite often, and it'll still open. The implementation varies enormously on what you can get away with. And whilst there's tools out there, many of them are not up to date. So PDF2 is very badly tooled at the moment. So anyway, thanks to those people, the images from ironmoon.net, the original ChatGPT, this was a real portrait of me before I got involved with the hacking scene. It's only 3 years old. And thank you all for listening, and thank you for the wonderful Chicon team for putting this together, because otherwise, this would be a bloody strange thing to be doing this afternoon. Thank you.
Busted.